So I think we could begin the session on electricity tariff. So my name is Cedric. I'm from the University of Grenoble, Alpes in France, and I will share this session on electricity tariff. So we have in this session 3 speakers. I think each speaker could have about 20 minutes to present his work, and after I think we could have 10 minutes of discussion, and we have about 1 and 45 minutes, 1 hour 45 minutes in this session. So I think we had time to have a very interesting discussion. So I propose to you to begin the session with the first speaker, Levan Bezhanishvili. Sorry. Okay, thank you. So from Charles University. I use the floor for about 20 minutes to present your work.
Thank you. Please confirm that you can see my screen and you can hear my voice well.
Yes, we can see your screen and we hear you well. No problem.
Great. Good morning, everybody. Today, I would like to present a work titled as Wild Tariff Schemes Evidence from Georgia, prepared by Professor Alberini, Dr. Ščasný, and myself. Our research interest is to analyze how people understand and respond to different energy pricing schemes. Therefore, we are taking advantage of the particular tariff structure in Georgia. This is not the state of Georgia of United States, the country Georgia. Okay. Increasing block rate scheme is widely used in energy sector, where the most commonly used approach is when a household is paying a certain price per kilowatt hour up to a certain level. And for every kilowatt hour exceeding that level, the household is going to be paying a higher price only for each kilowatt hour that exceeds that level. This scheme is widely used not only in electricity and gas, but also in the water supply, as it's supposed to be used for conservations. There are 2 influential papers by Borenstein and by Ito. They are questioning whether people are actually responding to the marginal price, which is what the economic theory normally suggests. And they think that people are either responding to the average price or expected average price. Ito goes to the point of showing that if they respond to the expected average price or the average price, they actually consume more than they would consume if they were responding to the marginal price. On the upper part of the screen, you can see the graph of the marginal price, and one below is the budget constraint that you have for this kind of pricing. There is a kink that corresponds exactly to the block cutoff. This slope is different, and this is a conventional increased block rate. But in Georgia, it is different. Georgia's tariff scheme is really wild. We call this wild. In Georgia, if you are falling in the first block, you are paying a certain price per kilowatt hour. As soon as you fall into the second block, you pay, or third block even, you pay a higher price for all consumption. So we suspect that if you are forced to pay a lot more since you are falling in the second or third block, we wonder whether that's really getting people to pay attention to how much they consume. And one interesting fact to Georgia's energy system is that marginal price is equal to average price, as Georgia does not apply a fixed fee for every month. In this slide, we are simply just demonstrating the budget constraints for the increasing block rate system for Georgia, and you can see just three gradually increasing segments. On this slide, you can see the tariffs in Georgia started from January 2012 and all the way to present. Here we have the description of the marginal tariff in the first block, that are the lower ones, what you see on the screen. And first block meaning that they consume monthly less than 101 kilowatt hour. And the upper ones represent the third block, which is just heavy consumers. We call this heavy consumers consuming more than 301 kilowatt hour monthly. The blue line represents Telasi, which is the company. This is the name of the company, which is a company that serves the capital of Georgia, Tbilisi. And the gray line represents Kakheti. This is a company name that serves the Kakheti region. So on the chart, you can see that they changed over time. So in 2013, that you see they fell and then they raised again, except for Kakheti region, when they raised a bit later than Telasi did. And you can observe that red and orange lines, which represent the rates of heavy consumers, never experienced a reduction in tariffs. Yes. Moreover, they went up in different times. We are using this to construct two simple experiments. In one experiment, we are having the treatment that is a reduction in tariffs from 2013 to 2015, while the control group is going to be people that are large users. And in experiment number 2, the experiment will be just raising the tariffs. And at this time, control group will be the Kakheti region, while the treatment group will be Telasi or Tbilisi capital. These are our research questions. So we are going to try to find out if this type of IBR, with this type of IBR, there is any evidence of bunching, meaning if people are really trying to control consumption, we should be seeing a spike in the distribution of consumption in the correspondence to the block cutoffs. Moreover, we would like to see if we can rule out the expected average price as a determinant of demand, but this is just for future research. And in addition, we will be looking at the experiment that I just described, if people are responding to the price changes and whether the responses are symmetric. We will also be analyzing the price elasticity. Regarding data, we have two sources of data. One source is the data that was provided by regulator, and we have a sample of Telasi and a third electricity provider, which is called Energopro Georgia. We have a sample of Telasi and Energopro Georgia's customers, bills and consumptions on the Tbilisi city border. Available from 2012 to the beginning of 2020, which is a panel of roughly 11,000 customers. And the second source of data is the household survey data available on the website of the National Statistics Office of Georgia. And data is available from 2012 to the end of 2019. It consists of more than 40,000 households, which is a rotating panel with households staying in the panel for 4 quarters, 12 months. The household budget survey, besides various socioeconomic parameters of each family, additionally provides electricity expenditure data from each household collected quarterly. But the household must report electricity bills paid in each month of the quarter. And since household budget survey doesn't provide electricity consumption, therefore monthly kilowatt hours is computed based on bills and tariffs. I'm showing now the map of the capitals, like Tbilisi's administrative borders. The blue line, as you see, is the border of Tbilisi. And as I have described in the previous slide, we have obtained bills and consumption information of the customers living near the border of supplier companies, Telasi and Energopro Georgia, from regulator. The red dots represent Energopro customers, while the blue dots are Telasi. Question: is there any evidence of bunching? And the answer is yes. We can observe this in household budget survey data, and you can see these red lines. These are just cutoffs of 101 kilowatt hour and 301 kilowatt hour. And the household really bunched to the left of the cutoffs. They really try to reduce consumptions as much as possible. As you can see, this also in the Tbilisi data obtained by regulator, while the left one is from household budget survey. You can see as well bunching here, but in recent years, we don't see bunching it anymore, neither in Tbilisi data obtained from the regulator, nor in household budget survey. And we believe that this may be due to an increase in households' income, that consumers are paying less attention to cutoffs than before, but this is a conjecture. This slide just shows the average total real household income over different years. You can see that it has an upward trend. So this might be one of the reasons why households stopped bunching. The next slide just shows the average monthly electricity consumption by a household over the observation period, started from January 12 to November 19. And you can see the seasonal fluctuations as well as the increase in consumption during the price reduction period, which is just from January 2013 to the middle of the summer, where we can see that the consumption increased. And when the tariff again increased, the consumption, we see the stabilized, like decreased over time. So research question 3, do households respond to the prices? This is a description of the methodology of the experiment. We are going to be doing the difference in difference type of study. It is going to be based on regressions, and we will be regressing the log of kilowatt hours of consumption and on a fixed effect of household, on a time fixed effect, and on a dummy that equals to 1 for treatment households only when the treatment is on, and 0 otherwise, and for the control group as well. And the delta coefficient that we are interested in represents the average treatment effect on the treated. And we also regress on the socioeconomic characteristics of the households, for example, like income, as well as the weather parameters like temperature, heating and cooling degree days. And for this type of study, we will be using a control group of high volume consumers, since the reduction in tariffs doesn't apply to them. Thus, in the control group, we will have households that always consume more than 301 kilowatt hour, and the remainder will be experiencing the reduction in price. Thus, they will construct the treatment group. And we can do this with 2 sources of data, with the household budget survey data and Tbilisi border data for the period January 2012 to December 2014, where a tariff reduction occurred. Since we are doing the difference in difference type of study, we need to check the trends before the treatment takes place. The blue dots represent the average consumption every month for the large consumers, who forms the control group, while the orange dots represent the average consumption every month for other consumers. And as you can see on the screen, high consumers have seasonal fluctuation, but they are very stable around the flat average level. They don't seem to be going either up or down. As for the treatment group, before the treatment period, they seem to be reasonably close in trends, while the control group, reasonably close in trends, while after treatment, they seem to be increasing as they are experiencing a reduction in tariffs. And we see this increasing trend. We are having a similar type of story, but for a tariff increase. This time we are using a sample that starts in January 2015 and ends in January 2016. We are taking advantage of the fact that Energopro Georgia and Telasi raised tariffs in July and August 2015, respectively, while Kakheti does not, Kakheti region does not. So Kakheti is going to be serving as our control group. Here is the presentation of the trends, and Kakheti is in blue and all others are in orange. It looks like prior to the application of a treatment, distances between blue and orange dots are similar, and you can see this. And after a treatment, the treated group experiences a reduction, while Kakheti doesn't fall, and they even have a slight increased trend. Finally, using data from a household budget survey, we are estimating a demand function. This time we have a similar type of setup, but we are putting in the log of tariffs. And you can see, log of the tariff is endogenous since we have increasing block rate. Therefore, we need to instrument for the tariff that is paid the average price, which is also a marginal price paid by consumers using the tariffs themselves. And these are the results of our studies. We find that the effect of the price decrease coefficient delta is 0.08, which is an increase in consumption by roughly 8%. And we observe like similar results on both sources of data, household budget survey data, as well as Tbilisi data, which is more precise because it was obtained from the regulator company, wherein the Tbilisi data, it seems actually the effect is bigger, roughly 10%. And the effect of price increase is estimated using household budget survey with the design we talked about before, where Kakheti region is a control group, and we find that as the price increase, the coefficient is negative 0.10. Thus, the average treatment effect is around 11% decrease in consumption. And finally, we estimate the demand function, and the price elasticity of the demand is roughly negative 0.56, which is pretty large. But I want to mention that these are the preliminary results, and we are still like refining our findings. And as for conclusion, just to remind you, like Georgia applies to its households a tariff scheme for electricity consumption that is different from the one widely used in the world. There is a three-block tariff scheme, below 101 kilowatt hour, between 101 to 301, and above 301 kilowatt hour. In which a household pays a certain tariff for all consumption in accordance with the block to which it falls. And moreover, it appears that people were observing tariffs, at least at the beginning of the observation period, while and why people have stopped controlling their consumptions in recent yes, it's still a subject of research. And we are exploring like income possibilities or other type of things. And in this regard, our research group is going to survey households in Georgia to check their awareness regarding tariffs. And moreover, we have noted that people do respond tariff changes when they decrease and they increase. And on top of that, we have a fairly high price elasticity compared to many other places, for example, the United States. And this is also a topic for like further research. Thank you very much. Any questions, comments? I'm looking forward to hearing from you.
Thank you, Levan, for your presentation. I think we could ask, as we are few participants in the session, we could ask directly in live our question. And after, I think you could continue to ask question on the private chat. So is the audience do the audience want to ask a question? Levan? So I have a couple of questions on your presentation, and the first one is on IBR. I was wondering why in Georgia do you have IBR tariffs? Because I think these tariffs are asked two questions. The first one is it's more for overall savings rather than the management of peak periods. So I was wondering if in Georgia you do not have a problem of peak management. This is the first question. And the second question is that IBR could have a negative impact on energy precarity. So as you study the first block and the third block, I was wondering in the third block, do you have only consumer that want to consume a big amount of energy, or do you have in this category of consumer also consumer that are in energy precarity? So this is my first question on IBR.
In the third group, we have only like heavy consumers, which always consume more than 301 kilowatt hour before and after treatment period. Like we just like take this group because they never experienced decreasing tariffs. That's why like they serve us as a like control group, while for the rest like who had who faced some like tariff changes, who face like tariff changes, they are served as a treatment group. And regarding like why Georgia applies like IBR and whether we have some problems in management, I honestly don't know like the reason of IBR, because it has been like applied for many years, like maybe like 15-20 years, and maybe it's because of the like conservation, just to control that people don't consume much and people like control their consumption, because we are like electricity like importer. We don't export our energy, and we like import energy, and maybe just to somehow like save. But I'll try to like find out. Thanks for this question.
Okay,
because
so
I didn't have this in my mind.
My question is because I know that when you want to improve energy savings, you could decide an IBR. But if you want to manage peak load period, in my view, it is better to introduce time of use tariff or critical peak pricing to manage both the conservation of energy and the management of peak period. So it was why I asked to you this question.
Okay, this is a good question. I will try to find out yeah, for like future research.
Okay.
Thank you, really.
I have another question on your control group. In your talk, you mentioned that your control group was, if I understood correctly, the third block.
Yes, for type.
Yes.
For type reduction. Yes.
Okay, and I was wondering if you could have a control group in your analysis that is not, but I know you don't use field experiment or experimental economics to use your analysis to do your analysis. Sorry, but I was wondering if you could use a control group that is not a representative of the overall demand. And so I was wondering if you do not have some bias in your analysis because of your control group and the choice of your control group.
One fact that we found like a bit problematic is that the control group in this case just representative of control group don't consist of more than around like 7% of households. This might be the reason that we need to like look for other like control groups, but other reason I think like in this case like and we showed this in the on the charts that for a control group like we can use like heavy consumers because this like trends really like showed that we can use this control groups. They really follow this control and treatment groups. They really behave like similarly, while after like treatment period, control group just remains unchanged and the treatment group just started like increasing due to tariff change. And we thought that maybe we could use this as a like treatment and control, and this is our ideas, but we are still like working on this project. These are like preliminary results and we are refining, as I mentioned, our findings.
Okay, because the last question, you do not you use only data from other entities. You do not have experimentation to
right.
Okay, you use data available on websites from public entities or this kind
right.
of
right.
Of data. Yes. Okay, you do not use experimental economics, or you do not have some experimental consumers.
Right. Yes.
Okay, thank you very much, Levan. Do the audience have any question? Okay.
I see one raised hand. Tatiana Gas.
Oh, yes.
Yes, thank you very much. I want to know, is there any control of income of these groups? For example, at households, maybe it reflect on electricity or for big consumers.
Yes. Yes, thank you. Since we have household survey data, household budget survey data, we have like wide socioeconomic characteristics that the household statistics department provide us. But we also have a regulator company, regulators that provides only bills and consumptions of the household, since regulators don't know regarding income. But we can control income from household budget survey. Big consumers and low consumers.
Okay, thank you, Tatiana. I apologize, I haven't seen that your hands up. So, okay. Any more questions? Okay, thank you, Levan. So I think we could go to the second speaker. So Mohamed Hendam from the European University Institute.
Yeah, thank you for this. So shall I share my screen now? Do you see my screen?
So, yes, it's okay. And I think we can hear you. So you could begin your talk.
Okay, thank you very much. So this is Mohamed Hendam. I actually worked on the research topic that is electricity tariff implications of increasing adoption of behind-the-meter technologies in an African context. I worked in this research along with my colleague Team Schittekatte from the European University Institute, Florence School of Regulation, and also Professor Abdel-Rahman and Dr. Mohamed Zakaria from the Faculty of Engineering at Shams University. Well, starting with the introduction, we saw actually a significant increase of behind-the-meter technology adoption that was driven by subsidy schemes. And we have seen this with the feed-in tariff programs and with the net metering programs. However, currently, we can see that a PTM investment is even profitable, depending merely on the interactions between the retail rate, and the solar irradiation. And this actually is, despite being a societal and a governmental objective, it really raises some regulatory concerns on the tariff itself and the rate of the tariff, the cost recovery that the tariff will maintain of the regulated entities. Africa is not an exception from this. We have seen increasing behind the meter technology in the African context. And to shed some light on the African context, we have here the market structure of the single buyer model that we can see that we can see in Africa. In most countries in Africa, they are either a form or another of the single buyer, or even in a transitioning phase to such a structure. And in this single buyer model, we have the distribution company, that is the DESCO. It is procuring energy from the single buyer entity that has a monopoly over the transmission. And this single buyer entity is actually procuring energy from the generators, and those generators are either privately or publicly owned. And mostly they are committed, the single buyer is committed financially towards those generators through a capacity signal that may be in a form of a take or pay clause in the PPA, or even in a pure fixed charge that has to be paid annually or monthly. And this cash flow is actually is quite contrary to this energy flow. So the cash flow goes from the consumers, pay a regulated tariff, to the distribution company, and then the money goes to the single buyer, and afterwards to the generator. And this is quite different from what we can see in a European context, for example, where we have this typical retail unbundled model, where generators where suppliers actually do procure energy from generators, either in the power exchange or from or through over-the-counter contracts, and those afterwards those suppliers supply their customers and collect the charges from them. And as we can see here, we have two different charges. We have red arrow representing the regulated charges that the consumer pay to the supplier, and then the supplier take it to remunerate the network activities, that is the TSO and DSO, for their services. And then there is a competitive component, that is the blue arrow, that the supplier collect and again pay the energy, pay for the energy consumed from the generators. So a quite interesting difference to look at is that consumers pay two components of price in the EU, that is or an unbundled model, that is the regulated and competitive component, while in the African context or a single bar model, you have the consumers actually paying a fully regulated component, and that is the distribution company, which could be either privately or publicly owned, is also under a transfer price or that is fully regulated. So our questions here, what are the regulatory implications of the adoption of PTM technology under this structure, that is the single power model? And the second question, can we mitigate those implications through a better design of the retail rate? So we're going to look at this, but first we look at the literature. So, and we can actually classify the literature into two different segments based on the structure and the consumer decision modeling. From a structural perspective, literature looked at the EU liberalized model, and also we have another stream looking at the US with its some of their vertically integrated utilities. And from a consumer decision perspective, we have a literature in the EU did have a couple of papers on the endogenous modeling of consumers, meaning that they look at the dynamics of the consumer changing decisions according to the retail rate design and the retail rate itself, while mostly in the US context, we saw exogenous modeling of consumer decisions. So for them, they set a certain penetration of renewables or certain penetration of those PTM technologies, and these decisions are going to be input to the model itself. So for example, you assume that each consumer goes for a 10 kilowatt installed PV rooftop application, and that's exogenously how do you model it. But in the endogenous one, you limit it to the economics and the dynamics of the retail rate itself. So and actually in our methodology, we adopted the one implemented in the EU, but on the African context. So we took this endogenous model and implemented it on the context in Africa, and considering the differences that we saw on a structural level. So for the model, we did model a regulatory cost recovery constraint to ensure that regulated entities recover their costs. And then we modeled prosumers as an optimization function of their annual energy cost in the GAM software. And regarding the scenarios, we tested two scenarios. That is the high and low cost PTM scenarios, representing the cost of PTM today and in the future in 10 years. And we investigated two designs of the rate design, and we have an assessment, regulatory metrics to assess the results. And those regulatory metrics looked at 4 indices that are very important to regulators. The first one is equity, and it looks at the degree that the certain consumer segment, specifically the low-income consumer, are protected against redistributional impact of new rate design. In terms of economic efficiency, we refer to the degree that the economic signal, that is a price, actually align the interest of the private consumers and their decision with that of the system. So you look at the total system cost. And in terms of cost recovery of the single bar, we looked at the recovered percentage of the single bar investment. And similarly, we did so for the DISCO, and we looked at the recovered percentage for the distribution company. So as the diagram illustrates, we use an iterative approach. So we look at the consumer decision. Again, we take it to the consumer recovery constraint and to the regulated cost recovery constraint. We see if costs are recovered or not. And then we continue this iteration till we reach at equilibrium. Regarding the case study, we used the data from mostly from the Egyptian utility, and we have here an assumed PV load profile and an hourly load profile, And it's quite interesting to look at the current or the status quo implemented retail rate design, that is the increasing clock tariff. And we can see that volumetric charges here actually differ from a segment to a segment based on the consumption, based on the level of consumption. And we also have here the current transfer price components, that is the volumetric, and the capacity component at the high voltage, that is the voltage for the procurement of energy for the wholesale that's being carried out by the distribution company from the single buyer. Regarding the results of the status quo, it is quite interesting to look at the status quo in the high cost scenario, and we see that the increasing clock tariff design has actually maintained mostly the regulatory objectives. So not that much regulatory concerns on efficiency or equity, and zero for the DISCO, and quite a small amount for the single buyer. And this is actually justifies the favorability and the popularity of such retail rate design. But in terms of the low cost scenario, we see here some interesting dynamics. Of course, we see some negative efficiency concerns, that is positive efficiency outcomes. So this means that we managed to this means that the IPT in the low cost scenario managed to reduce total system cost by 6.2%, while it raised some equity concerns. And this means that costs, the energy costs or the annual energy costs has been increased for those low consumer segment. And for the cost recovery of the DISCO, we don't have, and for the cost recovery for the single buyer, we have quite significant one. This really means that we will have a future concerns, or the single buyer will have future concerns over recovering its costs. And if you look behind such a figure, we see that the transfer price did not really manage to efficiently recuperate all the investment costs that are incurred by the single buyer. And this means that the transfer price is not that much efficiently designed, because it is volumetric component is very high compared to its marginal cost. And most of this difference is actually used to recuperate sunk investment cost. And by avoiding energy sales, you avoid those sunk investments, or you avoid the revenues on those sunk investments. So this really highlights the need to revisit the transfer price. So we did so. So we changed the volumetric component of the transfer price, and we make it equal to the marginal cost, while remaining sunk costs are reflected in a purely fixed charge. And that's what is actually suggested by the economic theory. However, in terms of the retail rate, we keep it to the IPT. So still end users will see the increasing block tariff. So what are the results? Here we look at the low cost scenario, and we can see that efficiency concerns, or still are there. We have positive efficiency outcomes, and this transfer price design actually managed to completely avoid concerns of the single buyer and the DISCO on cost recovery. However, it did raise equity concerns. And those equity concerns, if we want to look behind, we see that in order to recuperate all the DISCO and the single buyer costs, there has been a need to increase the rate, especially for the low income consumers, and has increased by 18%. And this 18% is actually means also that other segments have been subject to it. And we look at the model, and we see that there has been a load defection of consumers of not only the high consumption segment, but also the medium segment. This would suggest actually looking further at the interaction between those three regulatory objectives. And in this slide, actually, we look at them. So we have here the cost recovery concern of the DISCO, and here the equity concern. And those dotted line represent different cap levels of the single buyer concerns over cost recovery. And if we can see here, the result from the previous slide, it did achieve 0% of DISCO cost recovery, and also 0% of single buyer concern, but it did achieve around 18% of equity concerns. If we look at the bigger picture, we see that there is a trilemma between the equity concerns and the distribution company concerns over cost recovery, and those also of the single buyer. And it's actually also interesting to see that for the distribution company, there are more than 100% cost recovery constraints. And this is quite interesting to look at and theoretically in the single buyer model, something that cannot happen in an unbundled model, in the DSO unbundled model, because basically what's interesting here is this DISCO sunk cost. This cost actually is not just about the investment cost or the sunk cost. Indeed, the DISCOs incur additional procurement cost, as we can see from a structural perspective. And if the DISCO is going to procure energy and also do its investments in the network, then there are more costs needed to be recovered, and this would create a deficit that even theoretically would go up to more than 100%. And this is actually due to the additional supply obligations. And this additional supply obligation suggests that there is an accelerated deficit spiral that would happen. And this is actually supported by the fact that the highest consumers, whom you have heavily depended on in recuperating system costs, and those who have been cross-subsidizing as a low consumer cost, are actually the first ones to defect from the grid if they see a significant increase in the rate. And this is actually remind us through an analogy to the situation that happened in California crisis 2000, 2001, where we saw that there were utilities, privately owned distribution utilities, were actually subject to an increasing upstream prices. And at the same time, the retail rate for them were capped at a certain level. And so this regulated rate that was capped did not reflect the increasing prices and motivated consumers to buy more and consume more, where at the same time utilities were under pressure coming from the upstream. Here the analogy is quite similar, because regulated utilities are now under an increasing pressure coming from reduced sales in downstream, while they still have to be committed to the same sunk cost to recover transferred to them through the transfer price. And the only way we see that the only way out from such trilemma is to move from a fully volumetric end-user retail rate to a more cost-reflective one that truly reflects the costs. And for this, we propose to use a differentiated fixed charge to complement a volumetric and efficient design of a volumetric component. For this, we made actually some adjustments. So we followed the economic theory that is suggesting that the volumetric component should only reflect the marginal cost. And for this, we use the average system generation cost, because we don't have the marginal cost data. It's not published. And for the fixed charge, we differentiated it from between consumer segments based on their historical consumption. And we see this is really feasible, because this has been the way it looked at consumers used to the fact that consumption is different, or the tariffs are differentiated based on their consumption. And the results actually of the DFC for the high cost scenario did manage actually to maintain the achievement of all regulatory objectives and did not achieve any concerns. While on the low cost scenario, we have actually also no concerns, but a positive efficiency outcome. That's exactly the one that we saw in the previous slides. However, actually, we need actually to look at some considerations for such design. Well, first, we saw that this differentiated charge is differentiated based on historical consumption. And for this, we see that this design can be related to cost driver, any of the cost drivers, that is the energy or the capacity. But in our methodology, we propose it to relate it to the energy, the historical energy consumption. And in terms of efficiency, we also believe that fixing this charge for 10 or 20 years is going to avoid inefficient incentives to change consumer behaviors. And that is quite crucial to the success of such a charge. Otherwise, it will be exactly the same as the IPT. And to avoid the defection, the possible grid defection that may happen due to this considerably significant differentiate fixed charge, we propose to use exit fees that has been proposed in literature that really sends also a true representation of the sunk cost in a form of a fixed charge for all consumers. Some regulatory takeaways from our presentation is that under low-cost scenario, PTM technology will not maintain its regulatory confidence and favorability due to the fact that there is a trilemma between those regulatory objectives, mainly equity, cost recovery of the single part and cost recovery of the sandwich at DESCO. Second, to address such implications, it's not just about a retail redesign. Rather, it is more about the design of the whole pricing structure, including this transfer price. And this actually would lead us to an additional argument for the need to implement a short-term market and in order to allow for better signals and to efficiently recuperate sunk generation costs. For the differentiated fixed charge that we proposed, we stress the fact that this is based on backward cost causation as to avoid any distortive allocation of resources. And also this can be supported with the exit fees implementation. In terms of implementation, it is better to start moving today to be ready tomorrow for the implementation of a fully differentiated fixed charge. And therefore, there is a need to move gradually towards such a charge till the time when PTM knocks the door. So thank you very much for questions. And I believe we can open the floor now for the questions.
Thank you, Mohamed, for your great presentation. So do the audience have any question? I have also a couple of questions. I'm wondering if in your results of efficiency, you include savings in network investments, because I assume that if BTM is developing, I think you could reduce network reinforcements, for example. So this is my first question.
Yeah, thank you for this question. Indeed, we did not include any change in the network topologies and any resulting costs. That could be a future work to look at, this would be interesting to look at specifically. I agree, because PTM, specifically if we're looking at the battery storage, can really replace network enforcement. Yeah, I agree. Thank you for this.
Okay, so I think you answer in your presentation, but I had in mind a couple of questions too on the tariffs and on the design of the tariff. I think when you invest in BTM, you could have some problem with the contracting power, because you could have some consumers that have invested in BTM, but will reduce their contracted power. So they reduce the payments, the fixed payments, or towards the DSO or the TSO. And so I think you catch in your model this kind of problematic.
Yeah, that's exactly the case. That's exactly what we're trying to capture. And specifically, we're looking at the resulting cash flow of such arrangement. So we have this single power entity, we have the distribution company, specifically the privately owned. And we have been focusing on this specifically actually due to the main reason with that, for those privately owned distribution company, they are owned by the private sector, and they receive a concession over a certain area. And this is mostly the case in Africa. So if you really want to maintain the feasibility of such model and to protect the investment in such area, you need to look at potential a change in the load in their sales. And those potential change in sales are exactly what is the PTM is doing for them. Yeah.
But I was wondering, because in your model, when you have some this kind of tarification, you show that two-part tariff is not so bad, I think. But you show too that we could DSO and TSO could recover their cost. But I was wondering if you are in a low cost for BTM. If you have much more investment in BTM, you should adapt your tarifications, and this tarification must go with perhaps some cross subsidies or an increase in cross subsidies between consumer, between current or usual consumers and between consumers that have invested in BTM. And so I was wondering, so you could achieve the equilibrium in revenues. I agree, but I was wondering if perhaps the exit fee you mentioned, but I was wondering if some consumers do not have interest to invest more and more and more, and so could the tarification increase the death spiral or not?
Could the tarification increase what, please?
The death spiral.
Yeah. Indeed, exactly as you said, if you have a change in those consumer decisions, and with the increase of PTM, you have more and more consumers with less and less demand. And those consumers, they are mostly those high consumption segment that you have heavily depended on them historically on recuperating your cost. And there has been cross subsidy. And now those consumers leave, you have to increase again the tariff rate. And if you increase it again using the same format of the tarification, that is the status quo increasing block tariff, you're not solving the problem. You're exactly adding more challenges to it, because you resort in such methodology to increasing the rate. You don't have any higher segment. You have a medium class segment, so you increase the tariff for them, so they defect from grid, and then you go to the low income class and you increase it for them. You are now subject to equity concerns, and yet still you will not recover the whole system cost. So what can be done for this is still the same. For those people you have depended heavily on them in supporting the recuperation of your system costs, you still recuperate the costs from them, but in a different, using a different charge or a different signal, a one that does not motivate any change to their behavior. And the only charge that can do so is a fixed one. So it is fixed in the essence that it will not distort their efficient design. So if these see that the incremental cost for renewables for the BTM technology is much lower, they go for it. But still, they have to continue paying those fixed amount that were incurred in the past based on the expansion of the network to serve their supply. So this for the fixed part. And how can we design this fixed part? We say that, okay, let's go for differentiation. Again, historically, and tariffs has been differentiated based on energy consumption. We can continue in this direction, but at the end of the day, it's in a fixed format.
If I can come in as co-author, because the death spiral is a very well-known phenomenon in the European, Australian, US literature. But actually what we see here is an accelerated death spiral because of two problems. One, you have this IBT, inclined block tariff, which is not common in Europe, maybe some parts in US. And In Australia, also not. And that means that actually the ones that you already depend upon are the first ones to go. So it's kind of accelerating the spiral. And the other thing is that these discos they're not only DSOs as we know them, they are DSOs plus retailer, but the price they pay for energy is this volumetric transfer price, which is actually a lot higher than the pure, let's say, average weighted cost of energy. So they do not only lose on not recovering their sunk cost, they also lose on every unit of energy that they kind of overpaid due to the transfer price. So these two effects make this extremely rapid accelerated death spiral, and therefore it's a very interesting case compared to the already alarming death spiral in, let's say, the Western world. And the way we try to solve it is, as Mohamed explained very well.
Okay. Thank you, Tim, for this precision.
Thank you, Tim.
So, any question? Any more question? So, thank you, Mohamed, for your presentation and for the discussion. So, I think we could go to the last speaker of the session. So Arionmaro Simaremare for PTP Persero. So
okay, thank you very much.
Share your screen.
Cedric, I will allow me to share my screen for my presentation. Can you see it? Okay, good afternoon, ladies and gentlemen. Greetings from Indonesia. My name is Arionmaro Simaremare. I work for PLN Research Institute, the research division of PLN, the utility state-owned electric company in Indonesia. Thank you for the chance that are given to me to present our simple study entitled Electricity Tariff Cost Reflectivity and Time of Use Tariff in java-bali System. So my presentation will consist of 4 parts: the introduction, methodology, results, and discussion, and also the conclusion. Okay, let me start my presentation with the basic principles and also definition of public utility, which public utility is corporate entity that provides certain goods or service to the public, where in delivering these goods and service, it deemed more economical to be done by single or small entity. This requires some regulation on the price to be paid by the customers. The example of this public utility is electric utility, water, and gas. But maybe for some countries, Europe or Australian, electricity move towards the market structures, not the single entity utility. Revisiting bond rights principle of public utility, we have the principle for public utility tariff, requirements of revenue for the utility, just and fair allocation of costs among customers, and promoting optimal efficiency of resource allocation. And we will try to evaluate the existing tariff of electricity tariff in java-bali system based on these principles, especially and for the cost reflectivity or the generation cost. We already know that the cost of providing electricity, there is generation cost, which consists of fixed OM and variable OM costs. And there's transmission cost, mostly sunk investment cost, and also distribution cost, which is also mostly sunk investment cost, and retail management costs, and other tax and levies. And this study focused on, like I said previously, in the generation costs, the variable generation costs. So in all of this study, we will assume that the fixed and transmission distribution, also retail management costs, will be fixed for all tariff. We also already known about the generator's merit order, where the composition of generators that being operated varies at all time, depends on the load requirement. Generators will be stacked based on their operating costs and available capacity, starting from the lowest cost and goes up to the highest operating costs, and then the generator will be dispatched depends on the load, and the high operating cost generators will be dispatched when needed, especially at high load. But in the reality, not only economic consideration are being used, but also the technical consideration. So maybe even at the low load, we will still require to operate the high operating costs for the technical aspect or for the balance of the system. Common electricity tariff that being used widely, we have flat, fixed tariff, and also tiered tariff, where there is increase and decreasing block, time of use, base, shoulder, peak. We have demand charge, we have seasonal tariff, critical peak, and dynamic real time, which almost all of these tariffs have their own consideration, why they certain utility use certain tariff, but they also try to answer all the principles of the bond rights public utility tariff that are mentioned previously. Speaking of Indonesia or Java-Bali system in particular, this is the electricity tariff profile in PLN Java-Bali. We have a flat tariff, for the special purpose tariff, and also residential for the low voltage, and business or industry for the medium voltage, and the industry or high voltage. We can see that the high voltage customers pays lower tariff than the lower voltage customers, because in the tariff calculation, they will the lower the voltage, the higher the cost of grid or transmission and distribution to be incorporated. That's why the low voltage customer have the highest amongst the others. And also we have 2 period times tariff, which is the peak and off-peak tariff. We can see here we have peak tariff at 17 to 22 p.m. or 5 to 10 p.m., which is the peak tariff is 1.3 to 1.5 higher than the off-peak tariff. And then it is only applied for the medium voltage customers, not for the high voltage or for the low voltage customers. While on the other hand, residential customers only reside or only consume at the low voltage customers. So the residential customer will not be affected by this peak and off-peak tariff. Okay, methodology are being used in this study is very simple. We calculate the cost of electricity, I mean the cost structure of the electricity in Java-Bali system. We have generator cost, transmission and distribution and retail cost, which is this one, and then we can get the portion of fixed and variable costs from this cost structure, and then we evaluate the dispatch power of the generator. We calculate the generator dispatch power for 30 minutes interval over 1 year period, and also we obtain the generator operational cost, which is the variable cost. So when we combine this portion of fixed cost and variable cost, and then we can obtain the time varying costs for its customer segments. And then we find the correlation between the existing tariff structure and also the load profile. And then after we evaluate the existing tariff structure, we then try to propose the simple time of use tariff that can be used in the future. Okay, the result from the dispatch power of the generation, we can see that this is the typical dispatch of the Java generators in java-bali system. We can see that java-bali system is dominated by the coal-fired power plant, the gray area, and also the combined cycle gas turbine, which is the orange, light orange area. We can see that no significant change on the composition of coal and combined cycle, even in the weekdays and the weekends. And also we can see that the blue area, which is the open cycle and also the diesel power plant, only exists at the time of peak period in here. So using this dispatch power and also the variable cost of each generators, we can calculate the cost of generating electricity in java-bali for each hour in over a year period. And we have this cost of generation profile, the gray line in here. We can see that from 9 a.m. to 9 p.m. we have higher cost compared to the other period from 9 p.m. to 9 a.m. again. Yeah, comparing to the load profile of the java-bali system, we can see that the load profile and also the cost of generation conforms or in line with the cost of generation. We can see that the high cost of generation exists when the load is also high. Yeah, and comparing with the other load profile of each customer segment, from this we can see that in java-bali there is two period of high load actually, which is at the morning in here and also in the evening in here. The morning high or peak load is mainly contributed by the business and also industry customers, while the evening peak load period is mainly contributed by the residential and also the business customers. We can see that the business tends to constantly consuming electricity from morning to the evening. And calculating for the R-squared value, we can see that the total system gives good correlation between the cost of generation and load profile, while the industry, business, and residential give lower R-squared value, which indicates that shows low cost reflectivity. And when now we proceed to evaluate the existing tariff evaluation, like we said previously, the residential customers only have the flat tariff scheme, and with this tariff, we can see that there is no correlation between the tariff and the cost of production for residential customers. And for this tariff, also there is no incentive for the customer or signal for the customer to maybe reduce their consumption at this period of time. So if they increase their consumption in this period, then the utility will be suffer from the loss. While on the other hand, if the customer increase their period at this off-peak period, maybe the utility will gain benefit from it. But we are talking about residential customer, which mainly consume energy at the peak load period in this time. So we can assume that they will mostly increase their consumption in this period because there's no price signals for them. On the other hand, for the medium voltage customer, for business and industry customer, we can see that still same, almost the same from 0 a.m. till to 5 p.m. But at 5 p.m. they will increase their tariff, and with this tariff they have the signal to reduce their electricity at this period of time. But giving this comparison, we can see that the imposed tariff is much higher than the required production cost of the electricity. So it will give inequality for this type of customers. So it will give a cross subsidy for this type of customers. Yeah. So looking from this load profile, cost of generation profile, we try to propose a time of use tariff, while in the existing tariff, the peak period time is only from 5 p.m. to 10 p.m. while from the evaluation of cost of generation or cost of providing electricity profile, we can see that the cost is already high at starting from the 9 a.m. So we propose to shift the period of the high tariff from 9 a.m. to 9 p.m. and then for the low tariff period from 9 p.m. to 9 a.m. And we try to evaluate this alternative for the simple calculation because if we use more complex calculation, maybe it will be more complex to be implemented. So we try to propose a more simpler way. And from this evaluation, we evaluate how we evaluate is how these three alternatives will perform if the customers increase their consumption at the peak period or decrease their consumption at the off-peak period, and how how that impact to the revenue of the utility. And so from the evaluation, the alternative three give more favorable results because it still gives the utility fair amount of benefits, but doesn't hurt the utility even if the customers reduce their consumption at the low tariff period. This is the evaluation for the cost reflectivity of the proposed tariff. We can see that the proposed tariff is better reflective of the cost of production electricity, and from the R-squared value also increase compared to the existing tariff, which is 0 or 0.5 for the peak and off-peak tariff. And also from this, using this tariff and also evaluation, we can also found that using this tariff, the customers also incentivized to reduce their consumption in energy and at the peak period of tariff, and also increase their consumption at the off-peak period of time. Okay, and the conclusion of the future works for this study, or the simple study, is existing electricity tariff, either flat or peak. Off-peak tariff doesn't reflect the cost of electricity production very well, and flat tariff doesn't provide incentive for customers to adjust their energy usage. Existing peak off-peak tariff charge customers much higher than the electricity production cost at peak load period. And also this study proposed a very simple time of use tariff, which divide the period of over a day into only two period of time, which is the 9 a.m. to 9 p.m. for the high tariff period, and the other period. And from our evaluation, the proposed time of use tariff can reflect the cost of electricity production very well, and also provide incentive for the customer to adjust their energy usage at peak load period. But there is still in our future works plan to evaluate the perception of customers towards the proposed tariff and the impact on the energy usage at certain period for the proposed tariff. I think that's all for my presentation. Maybe we can have some question and discussion. I would more than happy to have discussion and answer the questions. Thank you.
Thank you, Arionmaro, for your presentation. Any question from the audience?
Hello, I have one question. Could you please first, again, show us the first tariff chart slide? I have a question related.
The first tariff?
Like with the peak tariff, the first slide of the.
This one?
Yes. I was this yellow one, because I see that this type of peak tariff is used for business and industry, but for I was wondering why they are applying for business and industry started from let's say 5 p.m. to almost midnight. One reason might be for example, restaurants when they operate actively in the evening. But besides restaurants, there are lots of other businesses that they don't need nighttime to operate, like shops, offices, and they could use morning time to fully operate. And what is the reason evening to pay in the evening so high tariffs for industry when they can use also maybe morning hours or night time? Yeah, I had this kind of question because I didn't. I mean, one explanation is restaurants really operate at night, but besides restaurants, what else? Offices definitely maybe no.
Yeah, thank you, Levan, for the question. May I answer? So regarding the time of the tariff, why they use 5 p.m. to 10 p.m. It's maybe because of the belief that that is the peak load of period in the system. I mean, they believe that the PLNs believe in the previous maybe previous years, they believe that that is the peak time of the load of the system, and then they try to impose higher tariff at that period to reduce that peak load, so that what they believe. And regarding why the business and industry, only the business and industry customers that are imposed those kind of tariff, maybe I can't give you a very certain answers, because I think it's more more political or something, because it is unpopular to impose higher tariff for the let's say the residential customer, because it will be more unpopular. While on the other hand, the industry and business, yeah, maybe they have the money, and if they have higher cost, then it will transfer their cost to their cost of products. So maybe it's kind of a maybe political or something. So, but regarding the time, it is years ago believed that this is the peak period, peak load period in the system. While after further evaluation, we found that in java-bali system especially, the peak load period appears starting from the 9 a.m. and not only at the 5 p.m. and to 10 p.m. Maybe for other system, for maybe in Sumatra or Borneo Islands, this will be true because maybe the customers in that system will be dominated by let's say residential, but in Java-bali system where there is so much more business and industry, the peak load tariff, the peak load period already started at the 9 a.m. So I think that's
yeah, maybe like the reason is that perhaps since this is like a very touristical place, maybe restaurants are dominating there, then some industry, and perhaps they don't produce much, but restaurants and business, tourist business is really active at night and in the evening time, and perhaps this is the reason. Okay, thank you.
Thank you, Levan.
Thank you, Levan. Any more questions from the audience? So I have a couple of questions. My first question is, have you access to more dynamic tariffs as, for example, critical peak pricing? Because when I saw your consumer profiles, I think you could improve the efficiency of your tariffs and your time of use tariffs if you have access to more periods of time, for instance, 3 or 4 periods in your time of use tariffs. And I think it could improve the network management and the consumer savings or the consumer's bill, because you could send more signals to consumers on their consumption and on the states of the network. So do you have access to more dynamic tariffs?
So regarding the more dynamic tariffs, in our opinion, we try to make the tariff as simple as possible, because if we try to put more complex tariff, there is also a study that said that the complexity of the tariff also may also affect the decision making capability of the customers. If they perceive that the tariff is more complex, then they will tend to ignore the tariff difference between each period. So that's one side of the story. And regarding the your suggestion that we may assess the critical peak, or maybe at 3 or 4 period of time period, yes, I mean in on the paper it will say increase the efficiency of the tariff, and it may give more signal to the customer on how their electricity costs. But like I said previously, it also need to be studied further by maybe giving a survey to the customers that we are going to do in the next the further study from this for this. So yeah, maybe on the paper it will increase, but reality may be slightly different from the paper, because it depends on how the customers will react or perceive the complexity of the tariff. Thank you.
Yes, I completely agree with you, but I think, at least on the paper, it could be interesting for you, because you could see if you had 3 or 1, no, if you decide a tariff of 3 or 4 periods according to your consumption profiles. I think you could have some savings and some cost, some better situation when consumer pays more in such period, but lower in other periods, and so you could have some savings that occur. And on the paper, I think it could be interesting to add this kind of study. And I have one more question on. I know that it is in your future work, but I was wondering if you compute the variation in energy bills for consumers of your new tariff. So I know this is future work for you. You present it in your conclusion. But I was wondering if with this new tariff, time of use tariff, do you have compute the impact on consumers' bill of this new tariff?
Currently, we haven't done that, but we try to done that by using the maybe agent-based modeling to model how the customers will react to the new tariffs that are imposed to them, on how it will affect their electricity consumption and also electricity bill, and it will maybe change their decision to find the optimum consumption. So currently we haven't done that, but in the future we are planning to do that. And also when we already have the maybe consumption change by the customers, we will then run it through again to the generation cost calculation to see whether this will affect the generation cost of the system. We are hoping that with this tariff, with this new tariff, the cost of generation will be reduced because of the flattened load profile. But that's in the future.
Okay. So it could be a first step to see the impact of this new tariff on consumer and to have some conclusion on the acceptability of the new tariff. So thank you. Thank you very much. Any more questions from the audience? No. So thank you very much for participating to this session. I think we could close the session. Thank you to all. Thank you for discussions.
Thank you very much,
Cedric, for your comments.
Cedric.
Thank you very much.
If I can just add a little request, could you please upload your presentations on the website? That would be great. Thanks a lot.
Okay.
Okay. Thank you.
Okay.
Thank
Bye
you.
For your technical support. Thank you.
Thank you.
I think we could close the session. Thank you. Have a nice day.
Have a nice day, everyone.
Bye.
Bye.